Hello everyone, welcome back to the channel. Today we are going to learn one of the most important concepts in programming, how programs are executed inside a computer. Whenever we write a program and click the run button, many processes happen right behind the scenes before we get the output. So in this video, we will understand how a program is executed in C, C++, Python and Java. And later we'll see the difference between compiler and interpreter and platform dependent and platform independent languages. Now, let's start with the C language. In C program execution, when we write a C program, it is stored in a file with .c extension. First, let me write the flow, how it is going to execute. So, we'll be having the source code in C language, and then we will be having compiler, and after compiler, I'll explain you how it is going to execute compiler, and then we'll be having object code, and then we'll be having linker, and then executable file, and then execution. So this is the flow how the C program is going to execute, guys. So I'm going to explain you this. So this is the flow, right? So let me okay, wait for 1 minute. Okay, so first we'll be having source code, and then compiler, and then linker, and then executable file, and then execution. So how this process is going to happen? So first take an example. Suppose we write print hello world. Sorry. Okay, suppose take an example. Let me write printf hello world. So in C language we are going to use printf, right? So printf hello world. So take this as an example. So the computer cannot understand C language directly, right? So therefore, this C source code is sent to the compiler. So this is source code basically. The computer cannot understand C language directly. So this source code is sent to the compiler. This compiler checks for errors, whether it have any errors, syntax errors, any type of errors, and if it is having any missing semicolons or variable declarations or any other uh, errors, if it is there, it is going to check, and then if everything is correct, then it will convert the source code into object code, guys. So of this is object code. After this compiler checks everything, if everything is correct, then this compiler is going to convert the source code into object code. So that is a object code. Now, this object code, next what will happen? This linker links the library files such as stdio.h, you know, right? Stdio.h. It links the library files such as stdio.h, and after linking, an executable file is generated. So now the operating system, whatever we are using, this loads the executable file into the memory and then it executes it. So basically important point is C is a platform dependent language. So any executable file created on Windows generally cannot run directly on Linux. So this is about the execution flow of the C language. Next, about C++ program execution. So C++ program execution is almost similar to C language, guys. So first same, let me write the execution flow. So first we'll be having the source code, and after source code we'll be having compiler, and okay, after, sorry guys, after compiler we'll be having same object code, and then after object code we'll be having linker, and after linker same executable file, and then we'll be having execution. We'll be having same process flow or execution flow like the C language only, same in C++ also. So basically, the compiler converts the C++ source code into the machine specific code, that is the object code. So the linker combines the required libraries, and then the executable file is generated and executed. So important point is both C and C++ is also platform dependent. So both execute the same execution flow. Both follow the same execution flow. There is no difference because they are platform dependent languages. Dependent languages, like how the program execution takes place in C and C++. Now let's see about the platform independent languages, that is Python and Java. So Python follows a completely different approach, not like C or C++. First, let me write the process flow. Okay, first we'll be having the Python code as usual. So Python code. So how will we save Python code? In the extension .py, right? And then later, this Python code next be converted using the interpreter. There will be used to have compiler, right? But in Python code, like you'll be having interpreter and then execution. So only 3 steps. I'll explain you what happens here. So basically, Python uses an interpreter. Instead of translating the entire program at once in C or C++, in Python program execution flow, it translates and executes one statement at a time. So basically, interpreter executes one line at a time. It doesn't execute entire program at once. Instead, it will execute line by line. Like print of hello, and then next print world. Okay. So print hello separate line and next print world separate line, guys. So now the interpreter reads the first line and executes it. Like print hello we have, right? The interpreter reads the first line and executes it. And then it reads the second line and then it executes the print world. So it will execute line by line. Interpret. What does compiler do? Compiler was executed like entire program at once, right? But interpreter executes line by line. It reads the line and then executes it. Again, it reads the second line and it executes it. So it executes line by line. So what are the advantages of this? Basically, easy debugging, faster development, next less compilation. And so basically, but even though it is slow execution, but we can have easy debugging. So Python is platform independent, as you know. If Python interpreter is installed, the same code can run on either Windows or Linux or Mac or Android, any OS. If Python interpreter is installed, then we can run the code on any OS without any modification. We'll see about the Java program execution. Java uses both compilation and interpretation, guys. So basically it uses both compilation and interpretation. So first I'll draw the process flow diagram. Okay. We'll be having the source code. We'll be having the source code and then this Java compiler. So Java compiler. Sorry, Java compiler. Java compiler will be there. And then we'll be having the bytecode. So after bytecode, JVM. And then after JVM, machine code. And then after machine code, execution. That is executable file will be generated. Right. So basically, when we write the Java program, that is source code, it is stored in a file with the .java extension. Like Python file, it is stored using the extension .py, right? Same in Java file is stored with the .java extension. So the Java compiler converts the source code into bytecode, guys. So it converts the source code into bytecode. And then after this Java compiler converts the source code into bytecode, the generated bytecode is stored in a file, okay, with dot class extension. So what is this bytecode? It is an intermediate code. It is not again a machine code. Machine code is different and bytecode is different. So it is an intermediate code. It is between the source code and the machine code. It is an intermediate code. Okay. So what is this JVM again? JVM stands for Java Virtual Machine. So its job is basically to load the bytecode what is generated and then verify this bytecode and then it will convert bytecode into machine code and then it will execute the program. So basically here we have two, that is Java compiler converts the source code into bytecode and this Java Virtual Machine will convert the bytecode into machine code and then the executable file is generated, then the program is get executed. So basically compiler generates the bytecode and the same bytecode can run on different operating systems using the Java virtual machine. This is called write once, run everywhere. As I told in the past video, write the program once and run it anywhere on any platform. See the difference between compiler and interpreter. So as I said in the beginning, I'll tell you the difference between compiler and interpreter. So basically compiler, what does it do? It will translate the entire program into one executable file. Okay. It will convert the entire source code or program into one executable file. Okay. It will translate one program or source code into executable file. Okay. At once it will translate entire program into executable file. But what about interpreter? As I told you in Python program execution, this interpreter, it executes line by line, right? Line by line execution takes place in the Python program execution. Line by line execution. So basically, this is the difference between compiler and interpreter. In compiler, it will translate one program into executable file entirely, but in interpreter, line by line execution takes place. That is example like Python. So for compiler, we can take example of C and C++. For the interpreter, we can take the example of Python. And compiler, like faster execution, and the interpreter, it is slower execution, as I told you. Like compiler generates the executable file, but in interpreter, we don't have any executable file, right? Because we line by line execution takes place. And then in compiler, errors are shown after the compilation. Before compilation, we cannot see the errors. So in interpreter, errors are shown line by line. As one line is being executed, errors can be seen after one line by line. Okay, so examples are for a compiler C and C++, and for interpreter example is Python. Compiler and interpreter. Now let's see difference between platform dependent and platform independent. So in the past video I've told you right about platform dependent languages and platform independent languages. So basically what are platform dependent languages? So platform dependent languages are basically what? Dependent languages are basically C and C++. Okay. Platform independent are basically platform independent languages are Python and Java. So these are platform dependent languages C and C++, and platform independent languages are Python and Java. Because what are platform dependent languages? It can be run on the same platform. If the program is developed, if an application is developed on the Windows platform, it can execute only on the Windows platform. It will not run on any other platform. But platform independent languages like Python and Java applications, it can run on any platform. Irrespective of the platform it is developed, it can run on any platform. So this is about the platform independent and platform dependent languages. So C and C++ use compiler and are platform dependent. Python uses interpreter and is platform independent. Java uses compiler as well as the Java virtual machine and is platform independent. So bytecode is stored in where? Dot class file. JVM makes the Java platform independent. So this is about the quick revision of the video. So thank you for watching guys. If you found this video useful, like, share and subscribe for more programming tutorials. Thank you. See you in the next video.